I'm always a believer of thinking about scaling your products from day one. If you don't keep that in your mind from day one, then it's just a matter of time that your AI products are going to fall flat. Suppose I tell you build an LLM evaluation pipeline and this needs to be scaled later into the production. What are the components that you should keep in that evaluation pipeline? Few things that you may say is basically there has to be audit log of what is happening, there has to be a tracing of what is happening and few more things. But how do you think about those and how do you build a runnable or running pipeline? That's what we are going to build in this video. I am going to show you an end-to-end LLM evaluation pipeline, parts of which you can use in training and parts of it you can use in production deployment as well. Let's start without any delay. First of all, we should understand what are the challenges with large language models output evaluation. Okay, and traditionally the way our machine learning or deep learning outputs are evaluated is very straightforward. Why? Because we have a prediction and we have a target. We can compare prediction with target and we can say what is our accuracy. That's how we have been measuring performance of the model so far. Take an example of, let's say, fraud detection use case, classification use case, and suppose this is your actual data, I will say AT, and this is your model predicted data, I will say MPT. So actual data is fraud, your model says non-fraud. You can simply say this is not right. Actual data is fraud, your model says fraud, you say this is right. That is how we have been evaluating models all this while. But there is one difference with large language models. The difference is these models are non-deterministic in nature, which means it can produce different outputs for the same input. Okay, non-deterministic. It can produce different outputs for same input, and one more challenge here is your outputs may be right but may be presented in a different way. For example, if I query to my system what is capital of India, okay, what is capital of India, and here I will take three possible answers. First possible answer is New Delhi. Second possible answer is capital is New Delhi. Okay, and third possible answer is New Delhi is capital of India. Now take a moment and think which of these answers you will like more or you want your system to give. If you are simply choosing any one of the answer, that is not how production grade systems are built. It will depend on what is that you want to do with this output. I will repeat it again, guys. What is that you want to do with this output? Based on that, you have to tell to your system which is my more suitable output. But the challenge here is how do you compute the accuracy of these outputs? For that, you need to have something known as a golden source. Okay, so I will write here golden source output, golden source or golden data you can call it. Suppose based on my use case, I want the output of this query to be capital is ND. Okay, so this is what my ask is. This is how I want system to behave. But system can behave like this or like this. So I will have to measure the accuracy of my output against this, and hence this is called my golden source data. What I will do, I will take this and compare with my output, desired output. I will take this and compare with my desired output. I will take this and compare with my desired output. And I will say, just I am giving you some numbers, may not be correct. This is, let's say, X% correct, this is Y% correct, and this is Z% correct. And that is how we will evaluate the models. Now, evaluation can be done on multiple parameters. I will come back to those X, Y, and Z, don't worry. But evaluation can be done on multiple parameters. And In this video, what we are going to do is we are going to take three different kind of work. One work that LLM can do very well is called summarization. This is one work LLM can do. So this will be our one use case. The other use case will be Q&A. So basically we will have a query and we want LLM to respond with an answer. That is our second use case. And third use case we will do is entity retrieval. So we will give a sentence and LLM has to give us the entities in that. For example, if I say Steve Jobs, Apple, then it should say Steve Jobs, name of the person, Apple, name of the company, and so on and so forth. So entity extraction, Q&A and summarization. Three different use cases we will take. We will take two examples from this, all these categories, and we will run our project. But first of all, what is that we will be doing? As I told you, we will prepare a data with golden source. What is the meaning of this? The meaning of this is we will have our query, we will have our context, and we will have our golden output. Golden output means desired output. And this we will have for all these use cases. Okay, which means two examples from all these categories we will have: query, context, and golden. Once we have these, what we will do is we will pass it through LLM layer and we will get the response. Okay. Once we get the response, what we are going to do is we are going to compute those X, Y, and Z metric that I mentioned in here, right? So I mentioned about some percentages. This is our first layer of evaluating how the output is. So I will say compute XYZ, or you can think of compute user defined metric. That is our level 1. So in the bracket I will write level 1. After this, what we will do is we will pass the responses to the LLM as a judge. Okay, so LLM as judge, and we will ask LLM, hey, here is my data, here is my context, and here is my golden output, and here is the output I have received from the model. Take all these things and evaluate the output in 3 dimensions. What are those 3 dimensions? Those 3 dimensions are correctness, reasoning, and hallucinations. I will show you in code now, but just understand this is my level 2 of validation. Okay. What is my level 3 of validation? My level 3 of validation is nothing but human review. Human review. So we are building a 3-layered evaluation pipeline here. First layer, we will compute some metric by LLM evaluation metric. Second is we will pass it through LLM as a judge. Third is human can review and human can give its own feedbacks. And all these things, very important part of this project, guys, will have an audit log, will have a tracing, and will have a mechanism to see what happened when, who changed what was the actual response of the system, what was LLM as a judge saying, why something happened, when human reviewed, what did human give as the input. So entire project we are going to build now, and I am going to take you to GitHub and explain you everything now, and then we will run the code. Okay guys, so as you can see in GitHub, I have a LLM evaluation pipeline project here. And in this project, the very first thing I want to show you is the data that I was talking about. This is the data, and if you go inside the data, you will see that there are 3 categories of tasks. This is summarization task, extraction task means entity extraction task, and bottom 2 are Q&A tasks. Okay. Summarization, extraction, QA. And then you will see there is an input. For example, the first line talks about something to do with the global warming. And you will see I will ask the system to summarize this. So this is my actual thing, and in golden you will see that the summary is here. Okay, in golden you will see that the summary is here. Similarly, if I come to Q&A, you will see there is an input. Why can Python threads not achieve true parallelism? And there is an context. Okay, input, context, and you will see a golden here. Input, context, and in the end you will see a golden. So what we are doing is we are giving set of 6 examples here. What we will do is we will take this data and we will send it to LLM first. And we will ask LLM to, for example, summarize this. Once that comes back, we will create our own metric. And we will call LLM as a judge to give us scores on those 3 things I told you: correctness, hallucination risk, and reasoning. But first of all, to understand how we will measure the evaluation, I encourage you to go to Unfold Data Science and watch a video on LLM evaluation, build reliable AI apps, this one. Because if I keep on explaining what are different evaluation metric, that video itself is, as you can see, 40 minutes long. So there are various ways in which you measure the accuracy of a LLM output. What are those ways? I have explained here. You can watch this so that you will be able to correlate better with what I am explaining now. What is there in our project? In our project, there are few important files that I will walk you through. Okay. First is the data that you saw already. The main important file is eval_pipeline.py. What this will do is it will take the data. So let me open that file also, eval_pipeline.py. It will take the data and it will hit the LLM. For example, you can see here, it is taking the data from data folder, the data that I showed you now. It will load the data set, and if you can see, it will call the LLM. Okay, so here it will take the model and it will call the LLM and it will get the response. Once it gets the response, right, as you can see here, if task is equal to summarization, summarize the following text in 1 to 2 concise sentences. Let me make it little big. If task is equal to extraction, extract the key entities. If task is equal to QA, answer the following question based on provided context. So this way we will create the prompt and we will call the LLM and get the response, right? And then what we are going to do is we are going to take those things and start computing our own XYZs. Remember, I told you we will compare against golden source. So here I was telling you, right, we will compare against golden source. How do you compare against golden source? So here if you see, I am taking LCS length. That means I will take on one hand the model predicted output, on another hand the reference. For example, here I am computing row L, prediction on one hand and reference on other hand. And what we are going to see is what is the coverage. Okay, what is the coverage of tokens? That is exactly what this function will give. For exact match, we will see if the reference and predictions are exactly matching. For context overlap, we will see if prediction and context, how much they are matching. And if the task is summarization, we will take row L. If the task is extraction, we will take exact match. And if the task is QA, we will go for exact match and context overlap both. Because if you remember, when I was showing you the data, here you will see that in QA we were adding a context, but in others I think context is not there. Yeah, in QA we are adding context, and in others we have input and golden only. So for QA we want to see a overlap with the context as well. Okay, for QA task. So we are taking for context overlap as well and exact match as well for QA task. Then we will generate a aggregated metric. Aggregated metric is nothing but you can simply think of at a task level what is the output. So for example, at summarization level what is the output, or at question answer level what is the output, something like that. And then here we are running the pipeline. As you can see, data set is loading, judge also we are creating. So once you will see that LLM is predicting and metric are getting computed, then you will see it is judge is getting called and judge is scoring the responses. Okay, and where from this judge response is coming? So judge response is coming on the top, if you see, right? From judge import create judge, which means in our file there is a judge.py as well, and in this judge.py we are simply saying that take the golden answer. So see here, golden answer prediction, score each dimension from worst to best, correctness, reasoning quality, hallucination risk, and it will rank it in 1 to 5. So this is my level 2. So you remember I was talking you 3 levels. First level, we are computing the metric by writing those functions I showed you, context overlap or row L or whatever that is. Second level, LLM as a judge we are calling. Okay, LLM as a judge we are calling, and we are asking LLM, this is how it should be. Now please tell me based on these how it is looking. That's it. We will get LLM's response, and we will this is heuristic, don't worry about it. If system is not working or you don't have LLM, then it will happen, and that way we will call LLM and we'll get the response from LLM as well. And in eval pipeline, if you come down, you will see that one more important thing I want to show you. When it is running in production, then there will be different runs. For example, suppose one person runs it today and another person runs the same system after something has changed. Let's say system prompt is changed, or let's say in RAG the knowledge itself is changed. Something has changed in the system and I want to compare 2 runs. Which run is performing better? That is where this compare runs is there. What it will do, it will let you compare 2 runs and it will tell you, okay, this is how the 2 runs are looking as compared to each other on all those metric, level 1 metric, LLM as a judge metric, and if you have done human review, then human review as well, it will show what is the result of that. Okay, so this is the entire pipeline that it will run. So if you can see here human review is happening where I can approve, reject or skip or quit. That is level 3. So let me go ahead and try to show you the project first, and Gradio UI is your UI. So in my project, in my cursor, very easy to run this project. Again, you have to simply activate your virtual environment and launch the Gradio app. So let me launch the Gradio app. And one thing I want you to notice here, if you see inside runs now, nothing is there. Okay, nothing is there inside runs. But you will see that once I run the project, the run data will start coming inside runs. I will go here and I will say run evaluation, and you will see something is happening here, which means evaluation is running. And if I tell you what is happening when evaluation is running, so everything that is here in the eval pipeline, which means data will get loaded, model will get called, the internal scoring mechanism will work, then the LLM as a judge will come, and then it will be ready for the human review. All that thing is happening here. And what you need to understand here is how these are getting captured and how logs and tracing are getting maintained, because I always think from production point of view. As you can see, there is a data set checksum created. You remember I was talking about a unique key should be there for every run. It has loaded 6 examples. Model is GPT-5 Nano. So basically these are the settings you can do in your code. Let me show you that as well. Okay, that's in .inv, and .inv I have put in gitignore. So you won't be able to see that. But your LLM model GPT-5 Nano can be a part of .inv with OpenAI key. Whichever model you want to use, you can put here. Okay, it's very simple to run. Just virtual environment and then run. And I explained you this LLM as a judge. I explained you Gradio for UI. This is data set. In runs folder, your run related data will get stored. Requirements, basically Python dependencies, and evaluation pipeline. We have been talking all this while. When I do a run, then what all will get stored? Very important to understand this, guys. Understand this carefully. First thing that you will see is predictions.jsonl, which means model output for each example. Let me go to cursor and show you what I mean by this. I just ran it. Today is 22nd Feb 2026. This is the time, my local time. I ran it, and first thing you will see is predictions.jsonl. And here you will see this is model prediction coming. Okay, this is the prediction of the model. Okay, this is prediction of the model. Now one more thing will come, and that one more thing is metric.json, automated scores per example and aggregated. So if you go to cursor again, you will see there is this metric.json file which tells you that in summarization this is the score, in extraction this is the score, and in QA this is the score. This is the overall mean score. This is per example. If we go prompt by prompt, right, per example, these are the scores, right? The third thing you should understand here is judge.jsonl. As I told you, judge will do its own scoring. So LLM judge scores per example. And where is judge example? Judge.json. So judge has to score on correctness, reasoning quality, and hallucination risk. And there is an explanation of why judge did something. So this is that file. Correctness, reasoning quality, hallucination risk, and explanation for judge. Remember, all these things are inside same folder for the same run. Okay. And if you see here, there is summary.json. Very, very important file, guys. Run metadata and aggregate results. Come to summary.json, you will see a unique ID here. This is the run ID. This is the dataset checksum, means your unique ID. This run will be identified by this run ID and dataset checksum. This is the model on which this run happened. This is the judge on which this run happened. These many examples ran, and these are the metric. This is the same metric that came from previous one, and here judge averages are also coming. Okay. Take a moment to understand why we need to store like this for every run. And human review.jsonl you will see is blank. You see this is blank now. Why this is blank? Because I have not done any review yet. Let me go to front end and do the review. This is my front end. What I will do is, all those information are here also that we saw in the cursor, and I'm going to browse, and I'm going to summarization 001, the first example. This is my input about global warming. This is my golden, and this is my prediction. Now, as a human, when you read golden and prediction, then what is your thought? Let's read it. Global temperatures have risen 1.1 since pre-industrial times due to fossil fuel emission, and IPCC wants temperature could reach 1.5 C by 2030 without emission cuts. Prediction is global average temperatures have been rising this due to fuel. I think it's more or less same. So I will say approve, and I will say looks okay. Save review. What will happen if I do save review is, if I come to human review.json, you will see ID is this, verdict is approve, note is looks okay, and reviewed at. Very, very important again for auditing purpose. Who reviewed and when they reviewed. Right? Let's come and review one more. So come here, Q&A. Why can Python threads not achieve true parallelism for CPU bond? So golden is this, the global interpreter lock allows only, because the global interpreter lock allows only. Let's say I will say reject, not good, or not right, anything we can say. I'll say save review, and in your human review file this will come and sit not good, reviewed at this. Okay, this is how your files will look like when you do human review for one run. Now let me show you something more interesting. Suppose, as I was telling you, somebody comes and changes the RAG knowledge in the background, or somebody changes some parameter of LLM. For example, here I am calling LLM with some parameters, right? Let's say temperature or top P, top K, whatever I can give, right? With that we will be calling the LLM. Suppose someone comes and changes something here, changes something in knowledge base, changes something in system master prompts. So these are our master prompts, right? If someone changes something in these master prompts, and I want to see what happened to the system when that happened. For that, let's run one more evaluation for demo purpose. I am running one more evaluation, and what you will see is one more folder will get created. So one more folder will get created here. As you can see, 1616, one new folder is getting created. Prediction file comes first, so it has come. Now judge file should also come, and other files should also come. Prediction has come, metric has come, judge should come, and that the record keeping file should come, the audit file, this one, summary file, and judge should also come. So it's running and it will come now. Okay, as you can see, the judge file has also come, the summary has also come, and metric has also come. Human review is blank because we have not done any reviews. Now we have two files to compare. One was run at 1609, another one was run at 1616. So I want to compare these two runs. What I can do is I can come to compare tab, and this is my first run and this is my second run. I will say compare. At the moment you say compare, it will show you mean score difference between, let's say one run is called A, another is called B. So between A and B, what is the mean score difference? Mean is the average of your individual dimensions of goodness. Judge awareness A and B. So judge is taking on correctness, reasoning quality, and hallucination risk. You can see how A is performing against B and what is the delta and what is better, what is not better. And based on this, you can again go back and choose what is the right system prompt or right knowledge base or right things to do. Okay, it's a very simple but powerful project, guys. This is how you have to structure your logs, and this is how you can involve human in the loop. Now I have a query for you. Normally you don't interact nowadays in comments for some reason, I'm not sure, but you have to tell me, in training and in inference, what can you use and what you can't use. So I showed you 3 layers of test here, right? In training and in inference. Can you use compute? Can you calculate those scores that I'm computing? Can you use LLM as a judge? And can you use human review? What is your recommendation, and what is possible and what is not possible when you are training and when you are in production? So training means you can take a fine tuning or anything, and when you are in production. Just let me know how you will construct your pipeline in training and in production, and what data you will have, what data you will not have. Based on that only you can answer this. And if you are not giving me likes and comments, guys, then it's a signal that whatever I'm creating is of no value for you. So your likes and comments are basically motivation for me. So just keep giving that, and I'll keep coming with these kind of useful contents which will be effective for your production grade application journey. See you all in the next video. Wherever you are, take care, guys.